I will represent for a framework called IGL-DT for solving semi-supervised semantic segmentation problem. Semi-supervised semantic segmentation aims to improve performance using a small set of labeled images and a larger pool of unlabeled data. Current methods tend to depend on one model backbone or generate noisy pseudo-label. More importantly, they struggle to learn both high-level context and local detail effectively. To address this problem, there is a need for a framework that can learn complementary global and local features in a more balanced and adaptive way. Based on this motivation, we propose IGL-DT, a different semi-supervised segmentation framework with a dual teacher strategy. We also introduce global context learning to guide the student with high-level semantic context and local regional learning to refine variant local features. We also propose discrepancy learning to encourage the student to learn adaptively by mitigating over-reliance on a single teacher. Unlike conventional teacher-student settings that use similar architecture, IGL-DT deliberately combines a transformer and a CNN to extract complementary knowledge, resulting in a more robust and generalized feature learning. First, we will introduce about the global context learning, which help a student network learn high-level semantic information from a more powerful SwinUnet teacher model. This is done by extracting global representation from both models using global average pooling and comparing them. Next to the local regional learning, which is designed to help the student network capture more varying local details by learning from a high-capacity ResUnet teacher, which is strong at preserving spatial structure. About discrepancy learning, this discrepancy learning is introduced to revamp student model from overfitting to a single teacher, which can happen when learning from a multiple teacher, SwinUnet and ResUnet that provide different type of guidance. Combining these components, our overall framework can be divided into two training stages, college teacher retraining stage and student learning stage. In the teacher retraining stage, the two distinct teachers are trained using cross-pseudo supervision framework, allow them to learn mutual knowledge and generate more reliable pseudo-label for the student model. In the student learning stage, on label data, the student model is trained with both strong supervision and teacher-student consistency. The supervised loss involves students to have accurate semantic prediction at the visual level. The consistency loss with pseudo-label guides students to match with the pseudo-label output from the two teachers. To leverage unlabeled data, we can alternately between two states, each focused on a specific teacher and learning objective. In the stage 1, which can be called global context focus, when the student model learn global feature using global context learning. At the same time, the discrepancy loss is applied to ResUnet to avoid overfitting to it. In the stage 2, the load can be considered as a local regional focus. The student learn local feature via local regional learning, and the discrepancy loss is applied to SwinUnet. Additionally, a pseudo-labeling loss is applied using both teacher prediction in both mentioned state. By integrating these components, our framework enhances the generalization ability of a student network, allowing to effectively capture both global semantic information and local contextual detail. In the main results about the quantitative result, on the backscan VOC, our method outperforms strong baseline like core match and CCBC in both backbone ResNet 50 and ResNet 101. On this dataset, our method outperforms core match across all label proportion and demonstrate strong generalization, especially in open scene understanding. We also visualize our model prediction compared to other methods. The visual comparison shows sharper and more accurate segmentation and signals and significant improvement in difficult regions, uh, such as small object boundaries, and occlusion. Our method accurately segment the traffic size, pedestrian, and vehicle, often problematic for other methods. We conduct two application studies, including backbone selection and objective combination. We analyze the impact of the teacher model backbone types on the student performance via a backbone selection figure. We conduct on three settings and have the findings that the dual local yield more minor gains, while the dual global improve results significantly, showing that global context is more powerful. However, our method, global local, achieve the best performance, proving that complementary global and local features lead to better student learning in the semi-supervised segmentation. The objective combination table assesses how different loss functions contribute to the overall performance. Based on this result, the global context have more than local feature alone, but when we combine global and local give the better result than either alone. And the discrepancy learning further improve the generalization by reducing overfitting to one teacher. In conclusion, combining transformer, global, and CNN global backbone provide the complementary strength, and when each loss component contribute uniquely, with the discrepancy learning play a key role in balancing the dual teacher guidance. This combination is essential to achieving state-of-the-art segmentation performance. Thank you for listening.